Hey everybody, starting chapter 4 today. We're talking a lot about functions this chapter. If you remember, we spent a couple chapters ago a lot of time talking about functions. The word function is really, really important. Hopefully you remember the word function and the fact that it passes the vertical line test. So remember both of these equations down here, they all pass the vertical line test. That's what makes it a function. But now we are going to expand upon that and even get a little bit more involved, as far as we have a very specific kind of function, which is called a one-to-one function. So first of all, it still has to pass the vertical line test. And the vertical line test, since it is a function, does mean that each x value corresponds to only one y value. That's from a long time ago when we learned what a function was. But what makes it one-to-one is that also each y value corresponds to only one x value. So remember how for functions it was the x value that couldn't be repeated, but if the y value repeated, that was fine? Well, now to make it one-to-one, neither one can be repeated. So we have each x value corresponding to only one y value. That's what makes it a function, period, which we already learned a long time ago. And now we can make it even more specific. If each y value corresponds to only one x value, that's what makes it called one-to-one. So one-to-one is a new vocab word. So if you remember, functions pass the vertical line test, but one-to-one functions also pass the horizontal line test. So let's analyze these two graphs here. First of all, let's determine if it is a function, and we already talked about how yes, this is a function. So I'll write yes func because it passes the vertical line test everywhere. The vertical line test will only touch the graph one time. But as far as being one-to-one, this one is not a one-to-one function because it does not pass the horizontal line test. So when you draw a horizontal line on the graph, it touches it twice, which is bad, which makes it not one-to-one. You could draw your horizontal line here. That touches twice. You could draw your horizontal line here. That touches twice. That is not a one-to-one function. Okay, so let's analyze this one. This is just a straight line. So vertical line test everywhere. Yes, it passes. So yes, this is a function. That's review from last chapter. But let's talk about the horizontal line test. Is there anywhere I can draw a horizontal line and touch the graph more than one time? No, so yes, this is one-to-one as well because it passes the vertical line test as well as the horizontal line test. Okay, so then we also have just a couple equations I can give you where it's not a graph, but I still want you to be able to tell me, is it one-to-one? And first of all, yes, these are all functions because it's in the directions here. Is the function meaning all 5 of these are functions? I'm just trying to figure out if it's one-to-one. So, like what we did in the last function chapter, if it's possible, I want you to think about what the graph looks like. So this graph, this very first one, this is a parabola. It's a U shape. It's pointing up. And this -4 here in the parentheses, remember how that moves it to the right 4? 1, 2, 3, 4. So here is what my parabola looks like. Is this a one-to-one function? The answer is no, because the horizontal line test touches the graph twice. So no, this is not one-to-one because it doesn't pass the horizontal line test. Okay, so what I want you to be thinking about is, what do these graphs look like? Let's go down to this one. This one is one that we just had a test over, I'm pretty sure. If you remember, this is a rational function with all the asymptotes. So if you think about what this graph looks like, I think that our horizontal asymptote is at 0 since the degree on top is less than the degree on bottom. I think I have a vertical asymptote at 4. 1, 2, 3, 4. So I'm going to draw that in. And I think my graph looks something like this. If I do like x-intercept, y-intercept, t-chart, blah, blah, blah. So let's think about this. First of all, yes, it is a function because it passes the vertical line test. Does it also pass the horizontal line test? Is there anywhere that I can draw a horizontal line and it'll touch the graph in more than one place? I do not think that it is going to fail the one-to-one line test, the horizontal line test. So yes, this is one-to-one. Okay, the asymptote is not part of the graph. It helps you make your graph. But think about just drawing a horizontal line here. That only touches the graph in one place. What if I draw it here? Still only touches in one place. What if I draw it here? Still only touches in one place. So this does pass the horizontal line test. Let's do a couple more. I'm going to skip this middle one for a second. We're going to come back to it because I don't know what that shape looks like. How about this snake one? Pretty sure I know what this snake looks like. Remember how it's down one and it's a snaky-like shape? Yes, it's a function. Does it also pass the horizontal line test? Yes, this is 1-to-1. I know what all these shapes of these graphs look like. This is a snake, but a sideways snake, this one. So the 2x minus 4 shifts it a little bit, but the point is that it's going to go through the origin somewhere around here. That's just a rough sketch of what the shape looks like. And again, yes, it passes the horizontal line test. So yes, this is 1-to-1. Now let's go back to that one that I skipped. Because here's a weird equation that I'm not exactly sure what it looks like. Yes, it's a sprinkler kind of thing, except the x squared makes it different. So if it was just x in here, yes, it would be a sprinkler, but the x squared makes it a little bit different. So I don't know what this graph looks like, and I don't expect you to know what this graph looks like. Here's the thing, is that we have to go back up to what the definition of 1-to-1 is. We have to think about how every single x value corresponds to only one y value. That's just for a function. And they already told us it was a function. So what I need to think about now is that each y value corresponds to only one x value. So what I have to do is I have to come up with one y value that goes to two x values. So I have to kind of think about what kinds of points can I plug into that equation that's going to make me verify that it either does or doesn't pass the 1-to-1 test, the horizontal line test. So think about this. What if I plug in 4 for x? Go ahead and plug in 4. So I'm taking the 4 and I'm plugging it in right here. I get 16 minus 16, which is 0. Is there another number that's going to give me 0 that I could plug in for x? This is a really hard way of thinking about this. So this is the way that I need you to kind of understand this 1-to-1 test that we're kind of thinking about. What if I did -4? What if I plugged in -4 into this x and squared it? That would give me 16. 16 minus 16 is also 0. So this is two x values, same y value. And it's hard to come up with numbers, but you're just going to have to kind of plug in a couple different numbers into formulas like this. And this is only when you don't know what the graph looks like. And let's talk about what this graph actually does look like. 4, 0 is here. -4, 0 is here. And this is actually a semicircle. It goes like that. And so yes, this does not pass the horizontal line test. There's my two y values. It also doesn't pass here. It doesn't pass here. So this is not 1-to-1. And that's because I got the same y value for two different x values, which made it not pass the horizontal line test. So that is a really hard example and some things that I just want you to start kind of thinking about. If you don't know what the graph looks like, you can still answer the question of is it a 1-to-1 function or not by plugging in some points for x and seeing if you get the same y value either way. I could have also done 2 and -2. That would have given me the same y value here, so that also would have worked. I could have used any number I want. I just did 4 because I know 0 is an easy number to think about. But you could have done any points that you want for x and plugged them in, and you would have gotten the same value for y. Okay, let's talk about what inverse functions are. So hopefully you've heard the word inverse before, and that's kind of what this whole section is about inverse functions, besides talking about 1-to-1, which was all up here. Inverse functions, think about inverse, to me it kind of means opposite. And so what they are is they're operations that undo each other. So I have these weird pictures down here, and this machine does this to your numbers that you put in there, and I need to figure out what this machine does to undo all of that work that the blue machine did. So what if I take three numbers, like 2 and 3 and 4, and what happens if I plug them into this machine? And what this machine does is it cubes all the numbers, because that's the function that this machine is doing, x to the third. It could be anything. Could be x squared, could be x to the fifth, could be x minus 5, it doesn't matter. But here's the equation, and what I'm doing is plugging in these x values. And so your job to figure out what numbers come out when I plug those numbers in. So when I do 2 and raise it to the third, the number that comes out is 8. And when I do 3 and raise it to the third, the number that comes out is 27. And when I do 4 and raise it to the third, the number that comes out is 64. 4 times 4 times 4. So now the question is, in order to illustrate like what is an inverse function, what can I do in this machine here that is going to undo all of the work that this machine just did? So what do I do? Do I cube it again? How do you uncube something? What is going to undo the work that the blue machine did? And what it is it's called a cubed root. So it's not like dividing by 3. It's not subtracting 3. It's a cube root of the numbers that I just did. So let's pretend like this cube root is this machine. So when I take 8 and I cube root it, the number that comes out is 2. And that's what I wanted because I undid the work here. I just undid everything. Here's another one. When I take 27 and I cube root it, I get 3. And when I take 64 and I cube root it, I get 4. So here's the point, you guys, is that let me kind of illustrate what's going on here. This function, x to the third, and this function are inverses. What this means is that they are exact opposites. They are opposite equations and they undo the work of each other. So if you cube something and then you cube root it, you end up with the original number. And there are a bunch of different examples of two equations that are inverses of each other. And that's what we're going to talk about next. Okay, so here's our definition of determining if something is an inverse. And what you have to do, and it's been a long time since we've kind of talked about these, but hopefully you remember this notation. When you do Fogg and when you do Goff for two equations like these two, if they both simplify to x, then yes, they are inverses. That's what this like formal definition means. So what I'm going to do is kind of write that off to the side. If you do, this is kind of like the English version here, the one that we'll understand a little bit better. If you do f of g of x and g of f of x, so you plug them into each other, and they both must simplify to x, then that means they are inverses. Okay, so we'll probably review f of g of x and g of f of x. They both must simplify to x, and if they do that, then they are inverses. So that's our definition. So let's look at this first example. What I'm trying to determine is, are they inverses? So the test for this is to first do f of g of x. And so what that means is all of g of x is going inside f of x, if you remember how to do those. So I'm going to do is write f of x with a big space where the x is. And in that big space is going to go the g of x, the x minus 4 over 5. Now all I have to do is simplify. So you can see first that these 5's will cancel, and I just have x minus 4 plus 4. And again, now the 4's cancel, and I just have x. So that whole thing simplifies to x, so that's what I wanted for that part. Now I have to do g of f of x and see if I get the same thing. And if I do, that means they're inverses. So what I'm going to do now is g of f of x. So I'm going to write that over here, g of f of x. So what that means is I'm plugging all of my f of x stuff into the g equation. So where the g equation is, I'm going to write a big space where x is. And inside that is going to go the g equation, which is 5x plus 4. And so first of all, what you can see is that this plus 4 and this minus 4 are going to cancel, because I'm just adding everything on the top. And that's going to give me 5x over 5, which is x. And I lost my x over here. So since both of them simplify to x, that means that yes, these are inverses. So I'm just going to write that here. Yes, they are inverses. This is the work that you have to show. You have to show Fogg equals x, and you have to show Goff equals x. Okay, 4 cool things about inverses. We are going to talk about that in class tomorrow. But what I want to look at for this example Just do these really quick. When you're given ordered pairs, it's very, very simple to do these. First, you have to make sure that it is 1 to 1. And that means that no y values are used twice. Okay, so remember, for a function, it's x values. For 1 to 1 function, that's y values. That's how it passes the horizontal line test. So I'm going to check these y values real quick. 4, -1, 6, -8. Yes, it's 1 to 1. Therefore, the inverse, here's the cool thing, you guys. You just switch the x and y. So I'm going to be given these ordered pairs. So instead of 3, 4, that becomes 4, 3. And instead of 1, -1, that becomes -1, 1. All you're doing is switching the x values. So 6, 4, -8, 8. Okay, so there's my inverse. All you do is you switch the x's and the y's, but you do have to check first to make sure that it is 1 to 1. Okay, so if we look at number 2, let's check first to make sure it is 1 to 1. 2, 4, 1, -1, 6, 4. Uh-oh. Y values repeat. So I'm going to draw a little arrow here, not 1 to 1. Here's a way to remember, like, how do you remember, is it x's or y's or whatever? You need to remember horizontal line test, but if I plot the point 2, 4, which is here, and also 6, 4, which is here, that is what doesn't pass the horizontal line test. Doesn't pass, and so that's kind of how you remember. If you need to do a sketch or whatever, you could do that. It's not 1 to 1, therefore there is no inverse. Okay, so not really a trick question, but you do have to check to make sure that it is a 1 to 1 function first. Okay, we're going to fill in the box when we get into class tomorrow. Guys, bring your questions tomorrow, and have a good rest of the night. Thanks for watching.